Hello everyone, today we'll talk about limited. Suppose you're walking towards a wall. You step closer and closer, but you never reach the wall. How close can you get? That's really just what limits in math are all about. So today we're going to learn about what limits are, why we use them, and how we can find them. In the graph, y gets super duper close to a number 0, but never quite touches it. A limit is the value a function approach, like since x gives 1 as x gives 0. The derivative is the limit of the average change of rate. This is a formula of the difference quotient. If f(x) equals xa, this is the formula. For example, how can we expand the derivation of f(x) equals xa by using limits step by step? Step 1. Write the difference quotient. We start with the definition of the derivative using limits. Step 2. Expand x plus h3. Use the binomial formula to expand. Step 3. Substitute and simplify. Plug the expansion back into the numerator. Step 4. Cancel h. Factor out h in the numerator and simplify. Step 5. Take the limit as h gives o. Evaluate the limit by letting h approach 0. So the final derivative of xa is 3/2. Here is a visual example. Physics. Rocket's instantaneous velocity as t gives o, and the formula is engineering. Bridge stress under load approaching maximum capacity. Economics. Compound interest as compounding periods gives infinity. So this formula becomes this. Limits aren't just abstract. They calculate instantaneous speed, predict system failures, and even model continuous growth in finance. So finally, let's expand a formula. Step 1. Plug in x equals 3. The numerator and denominator both approach 0 as x gives 3. We need to simplify the expression. Step 2. Notice that xa to 9 is a difference of squares. Rewrite the limit. Step 3. The x3 terms cancel out, valid since x3 in the limit. Step 4. Now substitute x equals 3 directly. So the final answer is 6. In our daily life, when do we use limit? First, driving and speed measurement. The car's speedometer shows instantaneous speed, like 60 kilometers per hour. The speed here is not average speed, but instantaneous speed. For example, radar guns use this principle to catch speeding cars. Second, economics. A business wants to find the ideal production level for maximum profit. Profit is maximized when marginal revenue, MR, equals marginal cost, MC, both defined as derivatives, limits. For example, Apple uses such models to optimize iPhone production. There are so many things around us use limit. We always use limit to predict instantaneous changes, like speed and growth. Model real-world systems like drug concentration, structural integrity. Also solve infinity problems like continuous compounding, asymptotes, and so on. So today, we learn about the limit, how to expand them, and solving in the daily life. Thanks for listening.